Hello everyone, let me begin by starting the series. We have 1, 2, 3, 4, 5. We have 5 parts in this project. Let me run the first. And at the end, we run a client. Now let's begin with press the first press, and the username is student, and password is and is already be saved. And second, now we can choose the country. We will select China, and here is the data from the website. Now let's quit. Okay, so here is the demo, and let me explain how this system is designed and how it reflects the principle of distributed system. This system adopts implicit distributed architecture. The main objective is to provide users with secure and efficient access to notional information and weather forecast. It consists of 4 core services and 1 command line client application. Each service runs independently and communicates through standard HTTP RESTful interface. This separation of cases allows for module development, easy debugging, and better scalability. Here is the client. The client is a command line interface written in Python. It provides 3 core features: user register, login, and querying country weather data. After a user login, the client automatically appends the JWT token to all focused queries, ensuring that only the other users can access the protected service. And here is the ISO service. The ISO service is responsible for registering new users and validating login credentials. Passwords are hashed using the SHA 256 algorithm before being stored, providing a basic level of security. For storage, we use a local XML field here. And this decision was based on the small scale of the system and the simplicity it offers. There is no need to set up a full database service like MySQL. And here is the aggregator service. Aggregator service acts as a central coordinator. It firstly checks the validity of the token received from the client. If the token is valid, it then performs 2 tasks in below. First, it calls the country service to get country metadata like capital city, population, language, region, and more. And second, it uses the longitude of the capital city to query the weather service, which returns 7 days temperature forecast. These 2 responses are then combined into a single user-friendly JSON structure and returned to the client. So here is 1, 2, 3, 4, 5, 6, 7 days data. And here is the country, and the capital is Beijing. A population, region, and area, language, and blah blah. It's all from the URL and all from this website. Now next is the country service. The country service acts like the wrapper around the REST country's public API. It extracts important fields like country name, capital, population, area, time zone, region, and languages. Just like I said. Now in the end, I will introduce the weather service. Similarly, the weather service uses the Open Metal public API to fetch the daily maximum and minimum temperatures over 7 days. It also implements caching and thread-safe locking to reduce dependency on the external service and improve stability. And this project is also follow the properties of the model course. It includes concurrency. The multiple users can send queries at the same time. Thread pools and caching help manager to concrete the requests efficiency. And scalability. Each service is a module and can be scaled independently. For example, if the weather service becomes a bottleneck, we can deploy more instances of it. And next is the fault tolerance. If one service fails, like the weather API being down, the system catches the error and returns a meaningful message without crashing the entire application. And reliability. API requests are warped with timeout to prevent blocking. Even if the internal services are unresponsive, the system remains stable. And transparency. Users don't need to see the internet complexity. They interact with a simple CLI. And that's all. Oh no, I forget the AI. And the course and the AI usage statement. In terms of code writing, no third-party example for templates were utilized, and all code were created by team members. And that's all. Thank you.